Hey guys, welcome to Math 1613, where we are going to be learning some trig. So today we're going to start off with section 1.1, angles and radian measure. So the first thing is we're going to talk about angles. So what is an angle? So an angle has two rays with a common endpoint. Most of the time you will hear that be referred to as the vertex. That is where the two angles come together, that endpoint. Because a ray is just an endpoint and then a line going on forever in the opposite direction. So as you can see with those two rays, it makes an angle, and we normally note that with a theta. Okay? So standard position is very important. An angle is said to be in standard position in the xy plane if the vertex is at the origin. Okay, so if you have forgotten, the origin is right there. And the initial side lies along the x-axis. Okay, I'm actually going to switch colors on that real quick. So I'm going to change that to green. And I'm going to write x-axis in green. And then that is the line right there. Okay, so remember that x-axis lies between quadrant 1 and quadrant 4. So if you've forgotten, yeah, it's okay. We'll just go ahead. No, I don't want it in green. Sometimes I get kind of picky about my color coordinating. So I'm going to go ahead and write that in blue. Between quadrant 1 and quadrant 4. So here is quadrant 1 and here is quadrant 4. And if you have forgotten some of that, I will re-go over that in just a second. Okay, to the direction of a rotation. So this is very important. The direction of a rotation is used to determine the value of the angle's measurement. So a positive angle will go counterclockwise. Okay, so I'm going to make a little note that we always start here because that's our initial side. And counterclockwise would be going up. And we normally show like that little curve with the arrow, so it shows the direction that we're going. Negative angles are clockwise. Okay, so remember you always start here. And of course, we're going to go down for that one. And then we will put our little arrow on it so we know which direction we have gone. Okay. If we go on to the next page, this is where I was going to re-go over those quadrants, okay? So we already know that this is quadrant 1 and this is quadrant 4. So what I like to remind students is we make a C. So notice when I made my C, I started in quadrant 1. So therefore this is quadrant 2, and then therefore this is quadrant 3, and then quadrant 4. So it is very important that we know which quadrant that an angle lies in, because later on it will tell us different things about that angle. So that's what we're going to practice real quick. So I have some examples, and it says, in what quadrant do each of the following angles lie? And is the angle positive or negative? So what I would like you to do is at this time, please pause the video and see if you can answer those questions, and then come back and play the video. Okay, so you should have paused the video. So the first thing we're going to answer is, what quadrant did each of the following angles lie in? So for this one, you should have said quadrant 3. Okay, and then because I went up, you should have told me that this one is a positive. I'll just put it right there. A positive angle. B, okay, should have told me quadrant 1. Again, I went up, So this is a positive angle. C, you should have told me quadrant 4. And because I went down, that's a negative angle from that starting point. D, you should have told me quadrant 1. And then notice I go down to get there. Okay, so I'm going all the way around like this. So that means negative because I went down. So hopefully we did really well in that section. Okay, but what about this angle? I'm sitting right there on the y-axis. So when the terminal side lies along one of the axes, it borders between two quadrants. So we call these quadrantal. Okay. So if you come down here, I'll just kind of show you those real quick. So I'll highlight them in pink for these quadrantal angles. You have one here at 0 degrees. You have one here at 90 degrees, one at 180, and then 270. And hopefully you know that a full rotation, which you can actually see right here as well, is 360 degrees. So a lot of through the class, as we're learning this, I will also write 360 degrees as well as 0, okay? Because we can do more than one rotation. So we can keep going and keep going and keep going. So angles are measured by the amount of rotation from the initial side of the terminal side. So notice your starting point is still right here. There are 2 units of measurement typically to do this. The first one you already know, which is degrees. So I want you to kind of see how the circle is kind of broken up, okay? Therefore, 1 degree is defined to be 1 out of 360 of a rotation, okay? Acute angles, I always liked when I taught geometry, I always said they were so cute, which means they had to be so little. So that is between 0 degrees and 90 degrees. So therefore, obtuse means it will be between 90 degrees and 180 degrees. But remember, it can't be equal to it because those are quadrantal angles. So acute and obtuse has to be in between them and not equal to. A right angle is 1/4 of a revolution, so therefore that's why that is considered 90 degrees. A straight angle, which would just be the straight flat line, is 1/2 of a revolution, so therefore that would be 180 degrees. So you can kind of think of it as 360 times a 4th. And so when you divide 360 by 4, you get 90. Here, half of 360. So we're dividing that by 2, which gives us that 180. So more of a visual kind of there with the math. Okay. Okay, let's go to page 3. So here on page 3, I want you to practice drawing these angles. I'm going to do about 1 or 2 with you, and then I would like it if you would pause the video and give them a try, and then see how well you did. So the one thing that I want you to somewhat practice is labeling the quadrantal angles. So that means I would go 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then like I said, I'll go back and show 360 degrees. Okay, so 90 degrees means I'm just right here for a quadrantal angle. Let's look at the 221. We'll just go ahead and go and do B. So again, I want to label them 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. So I am looking at 220 degrees. So as you can see, I am somewhere in quadrant 3. Okay, so let's think about this. I am past 180 degrees. So I want to know about how far I went past that. So off on the side, I'm just going to do 120 minus 180. Okay, so what is 220 minus 180? Okay, so hopefully you said 40. So that means I'm 40 degrees over. So that's about little than half, because half of 90 right here would be about 45. So I just want to probably draw a line that's a little less than half. So that would be half, so maybe about right there. And then I'm going to draw that I'm going in the positive direction. Okay, and then I want to do one more. So it'll probably be D right here, because I want to do a negative one. So I'm going to zoom out just a little bit. So this is a negative one. So that means from my starting point, I have to go down. So there's a couple different things you can do here. You can still do your 0, 90, 180, 270, and 360. Or you can do it backwards. You can go 0 degrees, negative 90 degrees, negative 180 degrees, negative 270 degrees, and then a negative 360 degrees. It is completely up to you. So 110. So I'm going to ignore the negatives right now. So we're just looking at 110. 110 means I would have to go past 90 degrees. So that means I'm sitting over here in quadrant 2. But how far do I have to go? So like I said, I just want to know how far I have to go. So I'm going to ignore those negatives. So 110 minus that 90 would give us a difference of what? Hopefully you'd said it, 20 degrees. So I want to go just kind of slightly past it. And there I am looking at my negative 110 degrees. Okay. So you are more than welcome to pause the video now and then come back and let's look at the other. How many would that be? 1, 2, 3, 4, 5. So go ahead and do that now. Okay. So let's go ahead and check these other ones and see how we did. So C is positive. So hopefully, again, you labeled that. So that means I am going slightly past 90. So remember, 90 is right here. So I'm going to go slightly past 90 for my angle. Okay. And like I said, once you get used to these, you don't have to constantly label them, but label them until you get used to them. Okay. E is 20 degrees less than 90. So I'm only going up to maybe about, whoops, that's probably a little too close. Let me draw that line first. Maybe like right there. Okay, these don't have to be perfect. I'm not getting a protractor out and checking your work. Okay. 160. So that means I'll go ahead and at least put the 180 on there and the 90. So you can see we are very close to the 180. So I'll probably draw my line about right there. Okay, because remember, this will be about 160 degrees, and this will be the remaining 20 degrees right there. Okay. Okay, 310. So I am going to write it on this one so you guys can visually see. So 0, 90, 180, 270, and 360. Okay, so notice I am definitely past the 90, past the 180, and past the 270. But how much past 270 am I? Okay, so off on the side, if you need to find out, 310 minus 270, and we have a difference of 40. So again, I'm not directly in the middle, so a little bit lower than that, or less than that, I should say. and then just show me the direction that we go. Okay, H was the second negative one for you to do. So because this is only the second one, I'm going to go ahead and put my negatives on there. And of course, that would be negative 360. So notice, this would be 90. This would be 180. But if I go all the way there, that's way too far. So we can do 270 minus 210. So that means I would be going 60 over. Oops, I didn't mean to erase all of those. So 60, maybe about right there. Okay. And there you go. Hold on. Let me back that up. Don't do that. You always go off the x-axis. That's way too high. Because the difference between 210 minus 180 is 30. So I went too high on that one. That is roughly about right there. So sorry about that, you guys. That's what happens when you're making your video a little late at night. Okay? So there we go. That one got fixed because I'm only going 30 past the 180. And so notice what I said. Never look at these angles based off the y-axis. And that is what I did. Everything is always based off the x-axis because that is where you start. Okay? So let's go to the next little section because this is where probably the new stuff kind of comes in for you. And this is where you're going to learn about radians. So another unit of measurement for angles is radians. The advantage to radians comes from the fact that their definition in is geometry based rather than just the one we do for degrees. So a radian is the measure of the central angle of a circle. So remember, the central angle of a circle comes from right here. That intercepts the arc length in the length of the radius of the circle. So if I was to zoom in real quick, notice, and I really wish you guys could see me, but it's kind of like putting your hands together and you're slowly opening them, but your palms are kind of, the base of your palms are staying together. And what you're doing is you're opening those palms up until you capture that radius. So it's like, because use my highlighter, because here's a radius, and you're opening this until you can capture that radius. And then when you do that, that is 1 radii. So it does not matter what the size of your circle is. So I didn't put like centrals in there, so add your little dots in. So notice this one is smaller. So this could be like a radius of a 1. When this opens up to also have a length of 1, that is 1 radii or 1 radian for that circle. If this circle over here had a radius of a 5, it would open up until that arc length was a 5. When I kind of drawn to scale a little too high there. Maybe like right there, I don't know. I'm terrible at sketching them. But it's going to open up until it captures that 1 radii. So that's kind of cool because what ends up happening, okay, you are opening these until you capture 1, 2, 3, and a little bit more, okay? Because this actually ends up being pi radians. So over here, if I kind of redraw this, I probably had it right the first time, okay? If the radius is 5, it's going to open up to have 1 radius, 2 radiuses, 3 radiuses, and a little bit more there, which pi is 3 and a little bit more. And so half a circle is equal to pi radians. So that means if you keep on going around your circle, this would be 2 radians or 2 pi radians. Okay, so because if this is 3 and a little bit more, and I have another 3 and a little bit more, we get 6 and a little bit more. And that is exactly what 2 pi radians is. Okay, so I actually also teach a class because I'm also a teacher at Eisenhower High School. And I love showing my students this video every single year. I love his energy, and I love how he explains what a radian is. So if I didn't do the greatest job on that little sections about explaining what a radian is, please go watch the video. You could pause me, go watch that real quick, and then come back. It's up to you. But radians at the end of the day is just capturing how many radii are going on, or how many radiuses are in that circle. If you go watch the video right now, it will dive into some other stuff that I will be going over here in just a little bit. Okay, so radian measure. Consider the arc length of a circle. So as you can see, this part out here is the arc length. Okay, that is going to be S on a circle of a radius that we have is R. Okay, the central angle, which is theta, you're always going to hear us refer to that central angle as theta. It intercepts that arc like we talked about. So therefore, that arc length gets divided by the radius. And if you think about it, that kind of makes sense. Like if I go back up to this circle that I have up here, okay, if I talk about theta and my arc length is R and my radius is R, I have 1 radian, and that is exactly what is going on. So if I come back down here, sorry for all the back and forth, we can actually use this formula to determine a different way of showing you that the total of 2 pi radians is a full revolution, okay? Because the circumference of a circle, so if I went all the way around a circle, that is 2 pi r squared. And when you take 2 pi r, sorry, I did not mean to say the squared. The circumference of a circle is 2 pi r. And then when you take that and divide it by the radius, again, we have proof that 1 revolution is 2 pi. So therefore, you will see a lot of your angles will be written as fractions rather than decimal answers. Now, I think your homework does practice a few decimals answers, but the majority of what we will do will be fractions. So here we go. What would the radian measure be for this central angle? So if you need to, look at the formula on the other page and see if you can answer this one real quick. So go ahead and pause the video. Okay, so you should have paused the video. So remember that your central angle is just equal to the circumference divided by the radius. So our circumference, the arc length. So this arc length right here is 30 feet. The radius is 8 feet. Notice your feet cancels, and you're left with 30 over 8. Okay, so these are both even numbers. So we're going to divide these by 2. So if I divide this by 2, I would get 15. I would divide this by 2, and I would get 4. So the answer for this central angle would be 15 divided by 4 radians. Okay. Okay. One important thing to note from the last example is that due to the units canceling, which will happen if you properly make sure the units are the same, the answer is a number without any units. as a result, those are radians. Radians are unitless. So you can write your answer saying with or without radians. So like for instance, that one isn't a decimal, 3.75 radians, or just 3.75. Preferably the fraction is better, and we're going to be practicing those even here in just a little bit. But like I said, I do think you have some homework problems that does both of them. Just be careful because degrees are still considered a normal unit of measure for angles. So when using them, please use the degree sign, because 10 radians is kind of like 10 radiuses. Is a little bit different than 10 degrees. Okay, they are different sizes and location of that terminal side. And if you if we forgot to write it down, it's wherever that other angle is your terminal side. So remember that this one is your initial and this one is your terminal. Because I can see if I drew the axis right here, this is actually in quadrant 3. Okay, and as you can see, it's 3.75. So it's over 3 and a little bit. Okay, so next thing we're going to do is practice a conversion between degrees and radians. So I want you to kind of think of it as we just learned, let me see where I squeeze it right here. We just learned that 360 degrees equaled 2 pi radians. So if I wanted to know what 1 degree equaled, I could divide both sides by 360. Okay, so that means this would go down to 1 degree, 2 would go here, and I would get 180. So I would get pi over 180 degrees. Okay, but think about it if I wanted to do it the other way. So I'm going to have to squeeze this one up here. 360 degrees equals 2 pi radians. If I wanted to divide by 2 pi, okay, 2 pi's would cancel. I get 1 radian. And so therefore here I would get 180 degrees divided by pi would equal 1 radian. And so that is where these conversions come from. So basically just think of it like this. If you're converting degrees to radians, then your degrees need to be on bottom. Okay? If you are converting radians to degrees, then radians need to be on bottom because we need to cancel out the correct units. So if you look at these examples, you can pause the video or go ahead and follow along. But if I have 60 degrees, I'm going to do my little conversion lines. Okay, that's how I do them. I need my degrees to cancel. So that means I need 180 degrees here, and my pi will go here. I need to see how many times 60 goes into 180. So 180 divided by 60 would be a 3. Okay, so notice that my degrees canceled. So I have a pi on top, a 3 on bottom. So you could say pi over 3 radians, or you could just leave it as pi over 3. If you didn't pause the video and you want to try the next one on your own, you can do that if you would like. So again, I'm going to draw my conversion bar. Degrees is on top, so I need 180 degrees on bottom, and a pi goes on top. So again, let's see how many times the 180 can be divided by 45, and that is 4 times. Okay, because negative 45 goes into itself 1 time and into 180 4 times. But notice that I'm actually left with a negative, so I have negative pi on top, 4 on bottom, radians. Okay. So if we go to the next page, page 6, okay? We're going to now do it the other way. We want to convert these angles to degrees. So I have radians, so now I have to use the conversion where the radians will cancel, which basically I need my pi's to cancel. So I'm actually going to rewrite this one because of the fraction. So I have 4 pi over 3, so I'm actually just going to extend that out, okay? So I need my pi's to cancel, so I'm going to put my pi here and my 180 degrees on top. So 3 can go into 180 60 times. Pi's cancel, okay? And so I have nothing on bottom, but on top I have 60 times 4, which is 240, and I have my degrees right there. So that would convert to 240 degrees. Okay, 1 radian. I don't have a fraction, so I'm just going to head and go. Just put this here. I have radians, so that means my pi has to be on bottom. And then this would be 180 again. So there's nothing that can cancel. So I have 180 divided by pi degrees. So I know that's kind of crazy, but you can box that up. If you don't like that, 180 divided by pi is roughly 57.296 degrees. So I would probably just leave it as the pi so that you don't have to worry about round off error or anything. But in your homework, if it does want a decimal, it will tell you how many decimals to round to. Okay, so degrees and radians can come together on that coordinate plane. So I want us to look at this, okay, and I want you to focus on quadrant 1. So quadrant 1 is right here and right here. So quadrant 1 goes from 0 degrees to the 90 degrees. So I want you to focus on that for now. So there's some things that I want you to take note of. One is, and I'm going to get rid of my line for a little because I went right through that. Okay. If you notice, the inside is degrees. So I'm just going to go ahead and say inside's degrees. I need you to focus on 0 and 360. And, oh, I went through that one too. So I'll do it like this and then like this. And so I want you to focus on that 90. But I also want you to focus what angle would be in the middle. Well, half of 90 is 45. So I want you to focus on 45 degrees. And then I want you to focus on 30 and 60. And you might be asking why, okay? So I don't know if you can remember back to when you had geometry, but there were those special triangles, 30, 60, 90, and there was a 45, 45, 90 degree triangle. Those are what we call special right triangles. So that is why I'm wanting you to highlight those. We're not going to talk about them today in detail, but I do want you to make a note of those, okay? Which means I want you to also make note of the radians. So if you look out here, it's the radians, 0 to pi, and pi over 2. 45 is pi over 4, 30, pi over 6, 60, pi over 3. So I just want you to kind of think about it. Let's just take 60. If I wanted to convert 60 to radians, then that means 180 degrees would have to be on bottom. So how many times does 60 go into 180? Well, the answer to that is pi over 3. And that, of course, that would work for all of them. But the biggest and most important thing is I want you to remember those relationships. I need you to know that 60 degrees is pi over 3. I do need you to know that pi over 6 is 30. So please make sure that you know both of those. And in just a second, we're going to talk about how to get them all over all the quadrants. And here we go. Okay, so technically you are getting ready to learn the unit circle. However, we are not doing the full unit circle. We are just doing a portion of the unit circle. Okay. Okay, so here we go. What color did I do degrees in? Okay, so I'm going to switch to green so I can try to keep them the same. So what I would like for you to do first is let's go put the degrees on. So we know that this is 0. We know that this is 90. We know that this is 180. I'm going to have to zoom out a little bit. Maybe right there. We know that this is 270. And then we know that this is 360. Okay, so we just learned that the middle is 45 because that is half of 90. Now, remember in the video when I accidentally messed up and went from the y-axis? This is where it's very important. So you always go from the right, from the x-axis. So the difference from 0 to 45 is 45 degrees. Okay, so that means I have to go backwards here 45 degrees. So what is 180 minus 45? Hopefully you said 135. Okay, so to get there, we had to subtract out that 45. So think about it. If I go to quadrant 3, I need to go forward 45. So think about it. We subtracted it here. So what would I have to do here? And hopefully you said add 45. So this would be 225 degrees. Okay. Here, I would actually have to go this way 45. So let's think about this. We already know this number is in quadrant 4, has to be between 270 and 360. So we're not going to subtract 45 from 0. That would give us a -1. So I need to do 360 minus that 45. And we get a value of 315 degrees. Okay, so guess what? We have to go do that for the other 2 angles. Okay, so up here, we learned that the other special one we're going to be learning is 30. Okay, get that kind of centered again. So this is 30 because I'm going up 30. So I'm come over here to quadrant 2. I got to go backwards 30. So I'm going backwards 30. So you should be subtracting 30. So what's 180 minus 30? That is 150. Okay. Quadrant 3, I need to go forward 30. So what's 180 plus 30? Hopefully you said 210. Okay. And then again here, I need to go backwards from that full circle of 360. So therefore, I'm subtracting that 30. So therefore, this is 330. Okay. Now, if you want to go try this last one on your own, you can. So that other last special that we're going to learn is that 60. Okay. So I'm going to put that 60 right here. So I'm going forward 60. So maybe pause the video and see if you can go get the other 3. Okay. So that means we're going to go backwards 60. So that means this has to be 120. We're going to go forward 160, so this is 240. Okay, and then again, we're going to go backward 60 from that full circle of 360. So this gives us a 300. Okay, so we just filled out our whole entire unit circle based off degrees. So notice this is your starting point. It's 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and 360. Okay? But guess what? We're going to go back and do it in radians. And I promise you that if you remember my little trick, we will be okay. Okay, so all I ask is I'm explaining how to get the degrees in radians. Please start practicing this. Make a empty circle or reprint this page. Practice this, practice this, practice this. You have to get it memorized. Okay, so let's go put what we know. This is 0 radians in 2 pi. And then we just learned that that's half a pi. Okay, so I'm going to put pi over 2 right there. Okay, we also learned that 180 degrees is pi. So I want you to see what's happening. It's like we're counting by a half. So that's a half a pi. A half plus a half is a whole. So what is a whole plus a half? Well, hopefully you said 1 and 1/2, but we don't use mixed fractions. So this is 3 pi over 2. And then when you add a half to 1 1/2, you get your 2 pi. So there is your quadrantal radians. Okay, so I'm going to erase that. Let's kind of do the same order. So we're going to go back to 45. And I know all these answers are on here, but I'm trying to explain to you how to get them because this has to be memorized. Okay. So if we come here and zoom out a little bit, we notice that this one is pi over 4. Okay. So the way that you can get these, and here's my little trick for it. The first quadrant, you always have to memorize. Everything about the first quadrant you have to memorize. If you can memorize the first quadrant, then I can help you get everything else about this unit circle. Because even after this lesson, we're not done with the unit circle. I'm going to have to come back later and finish it, okay? So if you can get the first quadrant memorized, you are doing fantastic. If that is pi over 4, we already know that we have to go backwards. So what I like to say is we minus 1. And everything I say is off the denominator number. So I am going to minus 1 from the denominator. And then that gives you a 3. So that means this is 3 pi over 4. So if you bear with me, this is 0, a fourth, a half, 3/4, and 1. So this is 0, 1/4, 2/4, 3/4, and 4/4. Okay, so that's kind of how this is working. So I'm going to leave that right there for a second. So if I go minus 1 in quadrant 2, we already know that we have to add going this direction. Okay, so if I have to add going this direction, you are going to add 1 of the denominator. So if my denominator is 4, we're going to add 1. So that means this is 5 pi over 4. Okay, and so see, that makes sense. That's 4 over 4, which makes 1. Adding another fourth is 5 pi over 4. This would technically be 6 pi over 4, which reduces to 3/2, which means if I kept counting, this would be 7 pi over 4, and then this would be 8 pi over 4. And notice 8 pi over 4 reduces to a 2. Okay, now I still have a trick for quadrant 4. So I'm going to erase this right here so I have a spot to put it. We already know we have to go backwards. So this one's a little bit different. So let's say this is, let's call this one denominator 2 times the denominator minus 1. Okay, so this would be, we can say, let me see if I can squeeze it in. Nope, it's 2. This would be denominator minus 1. This would be the denominator number plus 1. Okay, so the denominator times 2 would be 8. 8 minus 1 is 7, and that's how I got that. Okay, so let's go to 30. 30 degrees is pi over 6. So here we go. This is pi over 6. So that means when I go backwards to here, it has to be the denominator minus 1. So this is 5 pi over 6. When I go forward, that means that it is the denominator plus 1. So that means this would have to be 7 pi over 6. Okay, and then over here, it's denominator minus 1. So when I come here, I have to do 6 times 2, which is 12, minus 1. This is 11 pi over 6. Okay, and as you can see, that is exactly what they have up here. Okay, so like I said, the little arrows on the side are just kind of like my little trick to help you. You can still count it out, and I'll show that here in just a second. Okay, so let's look at 60. 60 is pi over 3. So get that right there. This one's pi over 3. So that means, so this is our 60. So that means this right here is denominator minus 1. So this is 2 pi over 3. If we go forward 60 from 180, or pi I should say, that means that we are sitting at denominator, which is 3 plus 1, 4 pi over 3. And then in the last quadrant over here, it is doubled. So 3 times 2 is 6, and then minus 1. So this is a 5 pi over 3. Okay, and so it would still work if we counted all the way through. 1 6. This would be 2 6, which reduces to the third. Okay, this would be 3 6, which reduces to the half. This would be 4 6, which reduces to the 2/3. Therefore, there you can see your 5 6. And this would be 6 over 6. You have your 7 over 6. This would actually be your 8 pi over 6. And then you have your 9 pi over 6, your 10 pi over 6, and then you have your 11 pi over 6, and then your 12 pi over 6. Okay, so I'm going to go and erase those because it's already crazy enough on the unit circle that I'm going to take those off. And right here. Okay, so like I said, this is the start of your unit circle. So please, please, please practice this, practice this, practice this. Because if you can get this down, then when I do the next part, you just have to add to it. Okay, so I went ahead and did that, hoping that it would kind of help you because we are about to re-practice our standard position, but this time it's with radians. Okay, so at least now you have your unit circle to help you some. So here, let's do a few examples together. So if you want, put your quadrantals on here. This is 0 and 2 pi, pi over 2, pi, and then 3 pi over 2. Okay, so notice that 2 pi over 3 is less than if I was to say this was 3 over 3, which made 1. So that means 2 pi over 3 is in this quadrant, in quadrant 2. So therefore, I am going to draw that. Okay. And if I'm getting this memorized, I also know that 2 pi over 3 is 120 degrees. So it's going to be a high one. Okay. So therefore, if you look at B, that means we have to go the opposite direction. So again, like last time, I can change these to negatives. So negative pi over 2 here, negative pi, and negative 3 pi over 2. But the cool thing is if this one is in quadrant 2, then I know that this one's going to be in quadrant 3. Okay. Let's do one more. I think I want to go to D, because D is a little bit harder, because I want you to notice the denominator. The denominator is a 6. So if you remember when I did 0 pi over 2 pi, and I did 3 pi over 2, and then I had 2 pi. I'm going to change colors. Okay, when that denominator, you can use that to kind of help you, because I know that this is going to be a 6 over 6, which is 1 pi. So therefore, I know when I come over here that this is going to be 12, 6. So from there, I only have 5/6 left. And so therefore, I know that this would have to be 3 over 6 because that's a half. So therefore, I know. So think about it. We did a full circle. So I'm going to do that for the full circle. Well, I have that 2 more 6 to go. So I know that I'm going to be sitting right here. Okay. Now, you can, if you want, and we're actually going to talk about this in just a second. You could have gone 17 pi over 6 and just subtracted 2 pi, knowing that it was going to be over. And you also could have figured out your 5 pi over 6. But either way, but notice I did one full rotation, so I did have to show that. Okay, so I'm going to go ahead and let you guys practice. And if you have any questions, I will go over them in just a second. So go ahead and pause the video. Okay, so now let's look at this. So hopefully you know that 7 pi over 4 is close to 8 pi over 4, which is that 2 pi. So I know that I am in quadrant 4. Okay. E is 3 pi over 5. So I know that this is 0 pi over 2 pi, 3 pi over 2, and 2 pi. Looks like I'm switching back to my pink now because this denominator is 5. So I know that this would have to be 5 over 5 to get the 1. This would have to be 10 over 5 to get the 2. 3 is less than 5, but I also know that 3/5 is going to be more than a half. So I am looking at an angle roughly right here. Okay. Next one is a negative. So we have 0, negative pi over 2, negative pi, negative 3 pi over 2, and I'm back at negative 2 pi. Okay, notice, I'm going to kind of approach this one different. I know that this numerator is my denominator plus 1. And originally, that is in quadrant 3. So, well, this time I ain't going to be in quadrant 3. So that means I'm going this way. So that's kind of going to quadrant 2. Okay, and remember the denominator of a 4 means you're at 45 degrees. Okay, so if you look at G, we got a big one going on right now because that is a 3. And that number on top is pretty high. So let's see what we got. I'll switch to blue to do this. So I got 0 and 2 pi, pi over 2, pi, and 3 pi over 2. So let's look here. So I know this would have to be 3 over 3. To get a 2, this would have to be 6 pi over 3 because 6 divided by 3 is 2. So I want you to think about it. I've already made one full rotation and I haven't made it to 11. If I do another one, so we've gone 1, 2, if I do 3 pi, let's think about that. That would be 9 pi over 3. And that would be okay. And then I still have 2 more. Okay? So we are now at right here. But where do I go? So that means I have done, let me see if I can squeeze it right here, 11 pi over 3. I have subtracted 2 pi, which is 6 pi over 3. I've gone another pi over 3. Well, let's just go ahead and do the total of a 9 pi over 3 because I think that will make sense. Those 3 radii, yeah, just the 9 pi over 3. So we've subtracted out 3 pi. Well, now I'm sitting at 2 pi over 3. So from this, 2 pi over 3 will be in this quadrant. Okay, so whichever way kind of works for you. That is why memorizing the unit circle is very important. Okay, the next one is 5 pi over 3. So again, I'm going to approach this one different. If you look at the denominator, this up here is 2 times the denominator minus 1. So that means I'm sitting in quadrant 3. Okay, this is why memorizing the unit circle is so important. On this page, I really only gave you one that was not on the unit circle. So if you practice your unit circle, it will help you in the long run. Now you might say, Miss Sorrells, you gave us a few more that was not on the unit circle. So yes, I agree, except for they were technically still on the unit circle, but we had to do one full, oops, that didn't go to color green. We did one full rotation, and down here we even had more than one full rotation. We had about, that was like 1.5, okay, and up there was a little less, okay. What happened on those is what we call coterminal angles, okay? So what coterminal angles are, 2 or more angles with the same initial side and terminal sides, but they could have different rotations, are called coterminal. So basically, if you pick a spot. So remember, I'm going to go ahead and just remind you real quick. Oops, I didn't change to blue. That this is your initial side. This is your terminal, because remember the terminal tells you where your angle's at and where it's located. So notice where it is. We are looking at quadrant 2. So if you look very carefully, if I can distinguish, okay, I think this is 1. So this is like the original angle, but you've got to realize that's not the only way I can get there. So like if I go ahead and change this to, let's say, orange, I can get there by going this way. Okay, but I landed at the same exact spot, so that's coterminal. You can even look at it on this one. I start here, and I'm going, and I do a full rotation, and then I wind up at the same exact spot, that is what you call coterminal. Okay, so if you are doing degrees, you can follow this formula if you want. K is just the number of full rotations that you do. If it's in radians, you can look at this one where you're just adding 2 pi times the number of rotations that you are doing. That is up to you. So like as you can see, for example, the angle 140, okay, 500, 860, negative 220, negative 180, negative 940. They are all coterminal angles because they are at the same exact spot, okay? They are all some type of multiple of 360 degrees. So we are going to practice that here, but the way we're going to practice it is I want you to give me an angle that's less than 360 or less than 2 pi. Okay, so if I'm sitting at 415, I am going to subtract 360 degrees from that. So 415 degrees minus 360 degrees is 55 degrees. So therefore, they are coterminal. So if I asked you to graph it, that's a little over a half. That would be 55 degrees. But then again, if I asked you to go graph 415 degrees, you would be going right back to that spot. Okay, that was a little messy, but okay. So let's do the next one. If I'm sitting at a negative 760, that means I've got to get above 0 but less than 360, okay? Because I want a positive angle less than 360. So I want to add 360, but that only gets me, whoops, left my negative off, negative 400. So I want to add 360 again, and that only gets me to a negative 40. So then I want to add 360 again, and then that finally gets me to 320 degrees. Okay. Okay, so the next ones are radians. It's up to you how you want to do this, but I would just subtract 2 pi. So I'm going to show you how to do it by hand. That means the denominator has to be the same. And remember, that's understood to be over 1. So 1 times 5 is 5, but 2 times 5 is 10. Okay, 17 pi minus 10 pi is 7 pi over 5. Okay, and that is less than 2 pi because I know 2 pi has to be 10 pi over 5, and guess what it is? 7 pi over 5, so we're good. Okay, the next one is 25 pi over 6. So again, I want to do the same thing. I want to subtract 2 pi. So I know I have 25 pi over 6. I need that same denominator. So that means this has to be 12 pi over 6. So that means I'm looking for a number less than 12. So 25 minus 12 is 13. 13 is not less than 6. So I have to subtract out another full rotation of 2 pi. Because remember, those are the same. And when I get done with that, I get pi over 6, which is less than 2 pi. So remember, when you are changing 2 pi, this is still the same thing as 2 pi. Same thing here. This is still the same exact thing as 2 pi. So you can kind of use that as your guide to make sure that you are getting under that, okay? I hope this made sense. If it didn't, send me a message on Remind. If you have homework questions, you can send those on Remind. You can email me. Reach out if you need anything.